All right, this is problem number 31 on page 370. We have a population of rabbits given by the formula P of t is 1,000 over 1 plus e to the 4.8 minus 0.7t. T is the number of months after a few rabbits are released. Show the function as a solution to the logistic differential equation. Find k and the carrying capacity, and estimate p of 0. So at time 0, what was the population? And explain its meaning. Okay, so we start with part A. They want a solution to a logistic differential equation. We remind ourselves, what does the solution look like? It looks like m over 1 plus ae to the negative mkt. I forgot my m there. Let's try that again. E to the negative mkt. All right, we write down our equation, which looks pretty close to it. I don't think we have a whole lot of work here to show that it's really a logistic one. We have 1,000 over 1 plus, and it's e to the 4.8. We don't maybe see that a right away. We're going to look at that a. We certainly see the e to the 4.8 minus 0.7t. Okay, so is this equation here equivalent to our solution to a logistic differential equation? Well, it matches up almost perfectly. Let's just work with it a little bit. So p equals 1,000 over 1 plus, and now this exponent, if I wrote it e to the 4.8 times e to the negative 0.7t, that means the same thing. And when I do that, I realize this e to the 4.8 corresponds with a. And once I have that, I see it is it's an exact match. I've got an m, I've got a 1, I've got an a, I've got e to the negative mkt. So I've got an exact correspondence. Maybe you don't want e to the 4.8, maybe you want a number for that. Well, let's give you a number. And we've got here e to the 4.8. That comes out to be 121.510. So use that, or use e to the 4.8, but clearly those two correspond. Okay, now that we know it's the solution to the differential equation, what's m, and what is, let's see, k and m. The carrying capacity is the m. Okay, well, we know m, look at that, it corresponds very nicely. M is 1,000. That's our carrying capacity. And then down here, negative mk corresponds with, mk corresponds with 0.7. So mk equals 0.7. Right, m is 1,000. So divide it, we move the decimal 3 times. So 0007 is our constant. So our carrying capacity is 1,000, and our growth rate, our k growth constant, is 0.0007. All right, now to part B. Can we estimate p of 0? We certainly can. We'll take our solution here. Let's put it as 0. This is part B we're doing now. Then I've got 1,000. I've got 1 plus e to the 4.8. And again, right there, I put in time is 0. 0.7 times 0 is 0. E to the 0 is 1. So I get this. And let's figure out what this is a little more precisely. I guess that's precise, but a little more. So we have a number to work with here. So I go 1,000. I'll divide by the quantity. 1 plus e to the 4.8. That's the last thing I just calculated. So let's just put in second answer. And I get an answer of 8.162. But we're talking about rabbits here. So we'll round that to the nearest whole number. So it looks like we have about, our initial population is about 8 rabbits, which means that's the number of rabbits we started with. And our max is going to be 1,000 rabbits. Not sure how long it'll take to get there, to get nearly there, but we're beginning this problem with 8 rabbits. So part B, estimate P0, 8 rabbits. The meaning is, at the beginning of this, when the rabbits were released, 8 rabbits were released. That completes the question.